Having a good Friday. Here I am staring at code again because, that's what I do for fun and not really profit. So here I am continuing to make Centipede. This is where we've kind of left off before. Let me go ahead and show progress of what we kind of have set up. Let's open in a browser, Firefox. Let me actually add back in the mushrooms so that we can see what that looks like. We'll go to our main game file and we'll do a quick view. Mushrooms to create. Let's create 20 of them for right now. So here we have our base kind of Centipede game. I have the Centipede moving across the screen. That seems to be working fine. I've created the would-be mushrooms. I've created the ship. I'll need to, replace a lot of this stuff with actual GIF images. Excuse me. I have it so that the ship has limitations. Excuse me again. On how high or low it can go. I have it so that it fires off what would be the bullets. When you hit the Centipede, it does leave a score. I also have it so that you can destroy the would-be spiders. Those also work. They move across the screen randomly, either from the left or from the right. I have it so that when you destroy a Centipede segment, it actually creates a would-be mushroom. So that's working. That's kind of where we're at for now. Now I've noticed that for the next phase of this, I want to actually introduce levels, so that the Centipede potentially either moves faster or we generate more mushrooms, things like that. So that's probably going to be the next stage of what I'm going to work on today. I've also noticed that the Centipede itself, the segments don't move correctly when we speed up. So part of the goal that I'm going to aim for is to adjust the Centipede segments so that they stay evenly spaced. That'll be it for now, and then figure out how level progression is going to work. Limit to so many spiders, so forth and so on. So that's where we're at now. So I think it's at a good spot. We have normal collisions. I think I'll have to greatly increase the number of mushrooms, and then once everything's kind of ready, I'll probably put it out there for people to kind of play and break and figure out things that are wrong. I think the other thing I need to do is clean up my collisions with mushrooms in the ship. But I think the key to that will be to work on how collisions go. So that's where we are right now. Let's go ahead and close this. The first piece that I'm going to actually work on is making it so that the Centipede stays, or at least vertically stays, a certain space apart from its parent. So let's go ahead and close you down for now, and let's go ahead and create a much more intelligent Centipede. And rather than calling it a Centipede piece, we'll call it a segment. So we'll grab you. Let's find our Centipede piece. Yeah, we'll create a new segment. And every time we, instead of calling you pieces, let's find all the references of this dot pieces. There's 19. So pieces, let's call you segments instead. And let's do a find and replace. Replace everything with this dot pieces with this dot segments. Replace them all. That fixes you. I don't know if I'm ever going to do the collision with the other centipedes. I think it's alright that it doesn't. Yeah. So Let's go ahead and look at how we're going to handle the centipede as it moves across the screen. I think what we need to do is have the, well, get segment, we're not using you. I think the approach that I'm going to take is for it, when it loops through and does the move, to look at the distance. So let's do some coding in here. Let's say look at the distance from the piece behind and the piece ahead. So that means that what we want to do is this dot speed. So they should all be moving at the same speed. But I guess we need to slow it down and look at, I guess we need to get the distance between first, let's see, we'll break it down into pieces. First, is there a piece, is there a segment in front of this? So if this dot segments I minus 1, if that exists, then we get the distance. So get the distance between the 2 points. And that distance should always be, what is it, 10? Yeah, the distance between the 2 points should always be 10. What is this dot diameter equal to? This dot diameter, so when we create a segment, yeah, this dot segments, this dot new, it's going to be equal to diameter of 10, and then we have the speed. So it should always be equal to the distance between 2 points. If the distance between the 2 points is less than that, then don't move it. Yeah, let's try that. If the distance, get the distance between the 2 segments. So const distance is going to be equal to, and it's 2 round pieces, and we have that code already, between circle and circle. So I guess we could say, yeah, I think in P5, yeah, I think we could just do P5JS and distance. Let's take a look at that. Yeah, between 2 points, so we want to get the distance, wait, hold on, distance between 2 circles? Yeah, let's do that. And it looks like collision circle. We actually want to not do the collision, we want to get the distance. Let's do this. And let's have it loop 1 time so that we can see what the distance is. So we'll do P5, we'll do distance. We'll grab you here. We're going to come over here and say it's going to be equal to dist. And it's going to be equal to We'll call this const parent segment. Parent segment. And we'll do a second one here. And we don't care about the one behind it, because this will take care of that. We want to know the distance between current segment equals this dot segment dot get segment. Yeah. And what we'll say is between parent segment dot x, parent segment dot y. We'll call you current segment object is going to be equal to current segment dot get segment. And then we can say current segment object dot x and y. X segment dot y. If the distance between us, and right now we just want to know the distance. Const, so we'll put a debugger here, and console.log distance. And we don't want to enable this just yet, but I guess we could try it. Let's see what happens. Let's open in a new window, browser, Firefox. Let's inspect. So we have our distance here, 11. So if it's ever less than the diameter, if the distance is less than this dot diam, we just exit, just continue through this loop, and we don't move it at all. So let's see what happens if we then speed this up. Let's go to our game. This dot centipede dot speed of 1.5. Oh, well that's terrible news. Yeah, that's not what I want to happen at all. Let's try that again. Bounce. Then let's see. Then you don't move horizontally. Then yeah. I guess we still need to move horizontally. But you're not moving quite right. Collided with the edge. So let's see what happens when that happens. We collided with the edge. Then move this distance, compensate. I don't think that's right. I think there's a couple different things that I'm messing up. So let's take a look at this. If the distance as we move, we only care about the vertical. So really, oh, well, who could be calling me? Oh well. Random phone call. Let's get the distance. And we don't want the distance to 2 points. We just want the distance on their x's. Because that's all we care about. We don't care about the y. Distance is going to be parent the math dot absolute of parent segment x. Yeah. Minus parent segment y. Da da da. Let's see how that looks. It's a little too far. So let's see. What happens if we slow it down a bit? Game. New Centipedes. Let's change it back to 1. Not quite. If the distance between... Oh, that's not quite right. It's fine to a point. It's just... So let's take this code out for now. And let's observe what actually happens. Let's observe what happens here. When it's at 1, it's fine. But when we do 1.5, what happens? Yeah, that's okay. Why did you speed up? Oh, I know why. So just 1 here. This is what I want to change. I want to change the speed up here for this one. So we bounce. And it looks like as it comes down, it's... If the distance between these 2 points is ever less than 10, and maybe we shouldn't do 10. Maybe we should do is ever less than 8. Less than 5. Yeah. If yeah, it's going to need to be like 8. I think that'll be okay. Nope. So we get the segment. We get the parent segment. If the segment exists, I minus 1. I guess we should speed it up. No. So we just want to know the distance between these 2 pieces. Just on the x. It should stay perfectly. I think I need to reinvestigate this math. So we want to move it over to the right. Then when it hits the wall, we need to tell it to move down exactly how much space. This dot vertical movement. We collide with mushroom handler. The vertical move is just the move distance, so it's always the same. Wait, no, it's not. Vertical move vertically is what? Move vertically And the vertical move is static to 10. So they bunch up. That's the problem. I wonder if it's something to do with the velocity. Let's take a look here. So we need to, I think what we need to do is instead of continuing is we need to reduce the velocity. Const adjusted speed. Instead of new speed, we'll call you adjusted speed. And it's going to be equal to this speed divided by a quarter. Let's do that. Divided by 4. And then we say this adjusted speed.x. So as it bounces, nope. Let's do 8. Bounce. It doesn't slow you down. Yeah, if it's less than 10. Let's bounce. Yeah, no, that didn't work. It should be a slower speed. So if the speed is 1.5, let's say 0.13. Yeah, that's funny. All right, let's change it to just 1. Nope. I'm thinking I almost want to revamp this to have much more intelligent segments. So let's go ahead and do this. Let's take out this code here. And what we want to do, we've done the follow code. So what we want to do is have it so that it bounces, moves down, but as it moves vertically, you should slow down accordingly. Let's see. Yeah, let's have it slow down accordingly. So I guess we need to know the position of a parent and its child. And if it's a mushroom, this dot horizontal move right. We move right, we bounce. So oh, so 10 pixels behind, but at the same particular point we also want to move. So how do we look now? At 1.5, this is what it looks like. Why is it doing it? Why is it? Because so it bounces, moves down. It bounces. It should. Let's reduce the length of the centipede and see what happens, because I think I'm missing something. Let's create a new centipede. Let's make it only 2. I want to see what happens with 2. Start, nope. 10, length 2. Bounces. And for some reason, velocity increases? The velocity between the two increases. And maybe we could do this instead. So in Centipede, instead of moving it x, we just move the parent and have the child stay 10 pixels behind it. Yeah, let's give that a try. So that's not going to work perfectly though. Let's do this instead. Let's move the first piece, which is going to be equal to, we'll move you up to 1. Current segment is going to be segment 0, and we're going to move it. Yeah. Yeah, we're still going to move it. Do all of these. We're going to move it. And then for the rest, we follow what we call the parent segment. We'll actually leave you all in here. So let's grab the parent segment. We'll call you the parent segment instead of the current segment. Yeah, parent segment. Yeah, let's do that. And then we'll take the current segment is equal to this dot segment I, and current segment dot dot get segment. Let's do current sector dot vector dot x is equal to parent segment dot get segment const static parent data is going to be equal to parent segment dot get data dot get segment, and that way we can say is going to be equal to this dot x plus 10. We want to move it, I guess, positively or negatively depending upon where the child is, or where the parent is. So if the parent is moved 10 over to the left, you should figure out your distance from the parent. Figure out distance from parent and move closer to parent. So const dist is going to be equal to let me see. There is a follow logic. What? I wonder if we could take the follow logic and P5 follow behavior. Let's go look. This. Follow you. No. P5JS follow. Take a look. Yeah. So we want to draw, and then we want to say dx Stroke weight. Okay, okay. Yeah, we get the distance between mouse S and mouse Y. Yeah, okay. Um, let's yeah, let's keep it that way. Let's do this. We get the current segment, and let's have it follow. We need to know the static parents x and y, which we have here. Dot x. Yep. Static parent dot y. And then we need to know the current segments x. I'm going to call you const static current segment. It's going to be equal to the current segment dot get segment. Yeah. So we have a u, and what we want to do is we want to get the current segments x. Nope. Static current segment. Yep. Dot x and dot y and d what dy? Where did dy come from? What dy? All right. Let's create some constants then, because I don't know where you're coming from. Const dx dy. Const. I don't know if we really need the angle. Dx dy. And then we actually need to know the positions. So yeah. So we'll do this. And the angle segment length is what, 10? This dot diameter, yeah. And this dot diameter, and then we just set this information to the current segments x and y. And let's see how badly this breaks things. Equals x, and current segment dot vector dot y is equal to y. And let's see. Let's see what that does. No, I don't like that at all. I don't even know if we need a vector, but that looks, it does bounce, but not in a good way. That looks terrible. That looks terrible. Let's see. Game. Take the first piece. Where's all our Centipede pieces? Yeah, I guess we're all right. So, add event listener, the length of 1. Yeah, let's see. So yeah, that only gives us 1. No, that follow behavior isn't going to work. So, let's take a look at this again. So we grab the current position of it. We really don't need the angle. Minus the cosine of the angle. We really don't need the angle, though. But I guess we should get it. Yeah, no, that just looks terrible. And I wonder if it's due to the fact that it's a vector rather than a position. No, that's not gonna work. All right, let's roll this back. Gotta find good logic for how I can do this. So the centipede just doesn't bounce correctly, and we need to find a way so that when it bounces, as we speed up the ball, it stays a bit better. So this follow logic isn't terrible, it's just a bit jumpy. Let's see what else we can come up with. Steering behaviors. Let's see what it looks like when we run it. That's not, I mean, that's a neat thing, but, and I might use that. That's a neat explosion, but no. I don't want to follow the math. Drawing vectors? Well, this looks interesting, so let's see what this looks like. And it does seem to follow it. Maybe that's what I should do, is create now a path. That's pretty cool, though. I wonder. So I think the thoughts are either try to make a more intelligent segment or try to use some type of grid, so that it follows the grid rather than specifically following and bouncing off of things. I wonder. So I wonder. Um. Yeah. So I guess the better solution is to create some type of intelligent segment that keeps track of the items around it that are fellow segments. And I guess we could just have it start off, instead of doing a vector, we could create a single parent segment. A single segment. Yeah, let's do that. Let's make a couple different versions of the segment. Let's create a generic segment, and then we'll break it off into parent and child. So we have our base class, which is going to be our segment, and it's not going to have a vector. It's just going to have an X and a Y. And yeah, no, actually, so we'll create a class segment, and we'll create a class parent extend segment, and then a class child extends segment. And so this will be interesting. I wonder how I want to do this now. So let's take a step back. Let's put all of you to the side for right now. Compensate for weird mushroom bug. Yeah, that makes sense. Let's pause this and let's create this segment class as kind of a much simpler class. Class segment. And what we're going to do is we're still going to have our base pieces. We still want to have it have a unique ID. Will it have an order? I don't know yet. We do need a constructor for it. So let's go ahead and do that piece there. Create the segment piece. We do need a diameter. We're not going to have a vector. We aren't going to let this have a direction, because only parent segments will have a direction. The child segments will just follow along with it. No bounce compensation, no allow vertical movement, and no hitting of the bottom. The ones just follow it. I think I might make it so that it behaves a little bit weirder. So it's just going to have an ID and a diameter for a segment, and then create a class child. Now children are going to extend their parents or extend segment, and all it's going to have is this.x, a constructor, which is going to consist of this dot x is equal to x, constructor props, I guess we need you. Yep. But we also need the x and a y. It's not x and this not y. All segments will have a draw function, which will just draw it basically. And then when we create the parent segment, we will need to convert this dot x to a this dot y. How do we want to handle this? I guess we actually do need a this dot y and this dot x. Otherwise, we can't put that on the parent or on the the parent object, the parent class. So this dot x, this dot y, diameter x and the y. Cool. So that'll be where it's created. This will be where we draw ourselves, and we don't want to do anything yet other than that. And then the child, it's already accepted that, and so it's just a dumb version of the segment. And I guess we could actually leave it as a base segment. Let's see. I guess we could just leave it as the base segment because there's really nothing else about it. But we do need a parent. The parent should be slightly more. It's going to have a constructor. You are going to have a vector. And let's see. Let's see what we did up here. You going to get the diameter. You are going to have a custom direction. This dot vector direction. Yeah. So vector will allow for a custom direction and vertical move is needed as well. So this props the custom direction, and let's see what else. A lot of vertical movement. This at bottom is false. And I don't know if we need all of that just yet. But, and we can always just re-add the original logic, so we kept that just in case. Vector, allow move vertically. And what we want each individual segment to do, and this is why I want a child segment. So class, yeah, child, extend segment. And let's put in a type here. This dot type is going to be equal to, let's create some static information. Helpers types. Export const. We'll call them segment types. It's going to be equal to object dot freeze, and we're going to have a type of parent and a type of child. Go over here to our Centipede and give it this dot type equals segment types dot parent, and this dot type is going to be equal to constructor. This dot type is going to be segment types dot child. And then we will have it so that there's a generic move, and the child should. Shall we draw? We draw to the x and the y, And I guess the child should potentially adjust itself for the parent. Adjust. So what we should do is we'll have it starting X and Y. And then if it's a child, we should look at the previous segment and find out our distance between that previous segment and follow along. How do we follow though? I guess we could implement the same follow logic as the rest. So we get the distance between the X and the Y. We get the distance between the 2 points, and we have it so that the follow logic, let's take a look, because we want to implement something like the follow logic, but not quite. Oh man, this is a bit of a complicated piece. Let's take a look at how some other people, there's some pathing logic there. All right, so there's a flock follow behavior. Let's take a look at, oh, it's not there. References. Hey, somebody's done something. Flock, huh? You see. So we create the flock. And do we just want to have it do a follow behavior? Maybe so. Apply the force vectors to acceleration. See, so it speeds up a little bit. Nature of the code. So acceleration is set to 0. And maybe that's what I needed to do, is start off the acceleration as 0. Add mass here. We don't have any mass. So we create velocity. And wonder if that'll be the better approach. Render theta with the position. Checks for nearby voids and steers away. Weight by distance. Maybe this is what we want instead. If d is greater than 0, p5.vector.distance. So this dot position, what is this dot position going to be equal to? So we use that, and we look for, what is it, the desired separation is 25. It's greater than 0 and less than that. Then let the diff equal vector.sub. Oh, I see. Weights by distance. Keep track of how many. And then steer.add. So we slow things down. As long as the vector is greater than 0, implement Reynolds steering equals desired minus velocity. Bunch of math involved in this. I see. So let's take a look here. I like it. I don't know if that's quite what we want path following. Create code. Sketch. No, not quite. Let's look for follow examples, because we kind of want the follow behavior, but not exactly. Like, that's not bad. I'm thinking that I might just change the centipede to just be a follow, kind of a little roundy. But I think that's what I'm going to go for. Let's take a look. Nope. Circle follows mouse. It's the distance that I'm running into, though. Simple follow example. I wonder, let's play around with this a little bit. Lerp. Lerp. Oh. What's lerp? Let's take a look. Lerp. I'm in English. Let's take a look. Lerp. Calculates a number between two numbers at a specific increment. The parameter is the amount to interpolate between the two numbers. Draw the original points in black. Draw the lerped points in gray. So let's go back here. And the X position, the speed. Huh, okay. So so we would have it follow. Yeah, let's try that. And then your new X and Y position is going to be equal to, yeah, let's give that a try. Let's come back over here to our code and adjust the X and Y chords. We'll create a new function here. We'll call adjust self. And we'll say this dot X, this dot X, this dot Y, and it's going to be equal to this dot X and this dot Y and the speed, which we don't have. So when we adjust self, and we're going to pass in the previous segment. So yeah, we'll do previous segment dot X and previous segment dot Y. So we have that. And I guess we need to know the speed. And I guess, I don't know how we're going to do that just yet. Let's see if we can make a single item first. This not allow vertical movement. We don't need you. We're not doing any vertical movement. We're just going to create a parent segment and one child to start. So create pieces. Instead, we'll call you create segment. And create segment. So no offset yet. Nothing here. For now, let's go ahead and create one parent. Const parent segment is going to be equal to new parent. And that's going to consist of, what are the props for a segment? It's going to be diameter X and Y. So we have diameter. The X is going to be what? This dot start X and this dot start Y. And what else do we need for a segment? We need vector and custom direction. Yeah, we have this dot start. Oh, I didn't put in the comma here. This dot start x, this dot start y. We need a new vector. So what did we do before? We created a vector. So we pass in, let's see, a new vector. That's also going to be start x and start y. Start x and start y. This dot. And what else do we need? Parent segment, vector, and custom direction. So we have all of this. And we don't go anywhere with it just yet. So that's the parent. And then we need one single child. And I guess it would be just easier to do this. This dot segments dot push in a whole new parent. And this dot segments dot push a whole new child in. And it's just going to be the same thing. We're not moving it anywhere just yet. We're just going to let that be what it is. Let's see if we get anything drawn here. Redecorate class parent. Oh, I left some code in here that I shouldn't have. Let's move you, grab you. Move up to here. Okay, so we have that, and it looks like we broke it, or I broke it. Parent segment not collided with it is not a function. Yeah. I'm getting to that. So we don't have you collide just yet. So we get you. Static parent equals, it's just the parent segment, and then what we say is for each of the segments, this dot is equal to, yep, the current segment, and then current segment dot, we have to adjust. Yeah, so we adjust. We have to adjust self based upon the previous segment. Dot adjust self from the parent segment. So that'll adjust it. We haven't moved it yet. We haven't done anything with it, but we have adjusted it. What we need to do is every time we move the parent vector, we need to call you again, move horizontally, new speed. Every time we move, we need to update the x and the y. So when we initiate this to do a constructor, we say this dot x is going to be equal to this dot vector dot x, and this dot y to be equal to this dot vector dot y. And I think it might be easier to eventually swap these out with vectors, but I'm not quite thinking clearly at the moment. I'm a little tired. So when we want to move horizontally, we'll mimic what we did up here, which is to, we take this dot vector dot x and then it'll draw it. Why don't we just move it x or y? I guess that's what we're going to do. Yeah, let's just move it. Yeah. I don't know why we're even using a vector. We'll just say this dot x plus equal horizontal direction, right, and it's the what, new speed? Yeah. Yeah, we'll call you velocity. was my velocity before? Velocity, 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 velocity. Oh, excuse me. This dot move horizontally. Is new speed x. What was our new speed based on? New speed. Oh yeah, this dot speed, which is all right. So yeah. So no, that's right. So velocity, velocity. So when we want to move horizontally, we would just come over here to the bullet. No. Yep, we would move you horizontally. So we would say parent segment dot move horizontally. And let's see what that looks like. Fine. Oh, I forgot to adjust the speed. I forgot to adjust the speed in the child. So we have the previous segment and the speed. And so do we want to follow too closely? Move parent segment and the speed. New speed.x. Yeah. Yep. Nope. Still wrong. What? Handle mushroom collision. Oh yeah, I left that in there. You handle mushroom collisions, handle bullet collisions. Roll up my messages and take a look and see what happens. Received an lerp. Let's create a breakpoint in our function to see what's going on. So we handled bullets, and again, I can always go back. Let's put a debugger in here and see what's going on. This dot segment. There's no breakpoint here. Okay, let's play you. Previous segment. Yep, it has a draw. Speed of 1.5. Okay. You know, I think what I also know I've messed up on. I think I didn't create a fill color. Oh, I totally did. Cool. So it's draw. So we loop through each of these. We create the segment, and then this dot draw. We loop through the segments and do a draw. And each of these has a parent draw where we fill it with this diameter. And the diameter is always going to be invalid number of arg expected 2 to 3. So props vector and custom. So let's go ahead and take a look at what happened. Props. Wait, what? Custom direction. No, that's not right. Give me a second. Jeez. Extend class. Extend date. This dot date. Parent class. Where are my props at? There's my constructor. Class. Yes. Extends null. Constructor length. Animal. Speak. let's see, I think I'm missing something. Constructor brand, constructor brand, mod. Yeah, so I think I messed up on my creation up here. So you should be this.diameter xy, this.diameter xy, this.diameter xy, this.diameter xy, this.diameter xy. Yeah, okay. So that should be correct. There it goes, which is fine. But where's our second child? Where is our child? So create segment, draw. Let's put a debugger here. And then let's inspect you to see. So we have a debugger in the wrong spot. I want to lerp. The segments is going to be equal to 1, type of child, type of parent. And I think the speed is too far. Let's adjust the lerp here to 10. Let's see what we see. And remove our debugger statement. We can always add it back in. I don't see the second item. Looks like it's creating it, but I don't see it. So adjust self, previous segment. Let's see, are there any errors? I don't see any errors. And so this dot draw should be drawing you. So for each of the child segments, we need to, so this is 1, the parent segment. And then adjust self. So your new in X and Y is this. Previous segments X and Y is that. Are we just not big enough? No, I see you over there. Let's take a look at that lerp example again. First of all, let's open you in a new tab. So we have you. Let's do p5.js lerp. Let's see what we can see. Let's see. Nope. Multiple interjections, interpolations? No. P5. Let's look at follow examples again, because I think we saw one that was here. Yeah, it was. It was this one. So, oh, I see. It follows closely behind it and then eventually lands on top of it. And we don't quite want that. So as it moves, and the speed is 0.01, so we want a slower speed. So should we do 0.1? 0.1, and let's see what that looks like. Yeah, there we go. So as it goes faster, should we do 0.05? Let's slow it down. Nope, point 0.075? Yeah. That's still a little too slow. Let's do 0.1. Yeah. And so then if we do that. Let's do a loop and see what happens when we create more than one. So we're going to loop through the length, and we push in this dot start x to y. We don't offset it so that it's perfectly fine. We create multiple child segments, and so then we have to loop through for each of them, and we don't want to just adjust the parent segment. We would only do that, we would create that weird if statement again. So if there's a parent segment, if this dot segments of I minus 1, yeah, if we have a parent segment, then we want to take the current segment and adjust the new speed. This dot segment, and instead of calling you parent segment, we'll just call you first segment. We'll call you first segment. You're going to move horizontally. Then get the parent segment. Get the parent segment. And then we pass that into our child. Which should we draw it? Let's see what that looks like. Nice. So then all we have to do is have the parent collide with the wall. So let's add this to collided with edge. So, and let's add this to the parent and see what happens there. Collided with edge. For all segments? No. We only want the parent to be able to collide with edge. And we get our margins, we get, and again, I don't know why we even need a vector at this particular point. We could just say this dot x is greater than margin right, or this. Then we do our boundary collision handler, which we have up here. And all the boundary collision handler does is it flips sides. So this will still be handled by the parent. We do this move. We don't do a bounce up. We don't do this. I guess we do this. Bounce compensation. How much was bounce compensation? I think it was 2. Yeah. So I guess we can leave that in here in the parent for now. And we're not going to move vertically just yet. Well, I guess we can. We can move vertically. And will they follow? Oh, we'll see. I don't know. I think it will. Move vertically this dot y and this dot x. This dot allow move vertically, and we'll keep some of that logic in here. This dot allow move vertically. Allow move vertically. Oh. And this dot vertical move. And we need this. There it is. So that bounces off the side and then bounces down. Let's see how that works. We bounce. Nope, we do not. Did we not? Oh, I know what we didn't do. I didn't enable the collision handling. Collided with edge. And you're calling first segment. So you, yep, I think that's okay. I don't have it colliding with mushrooms just yet. Am I okay with that? I don't think I am. I think I'd like you to move a little bit faster. 1.5. 1.5. No. 2. 1.1. 1.2. That's a bit better. Bounce off the sides. Let's see what happens when you collide with a mushroom, though I don't think I have that enabled yet. No. So we need to enable the collision with a mushroom. Handle mushroom collisions. Or we only need to handle the parent. So collided with mushroom. Yep. This will just be part of the parent. And let's see how it behaves. I think I'm okay with the more smoother movement. And yeah, I think I'm okay with the slower movement. And collided with mushrooms. We don't need to care about all the segments. We only need to care about the parent segment. So we only need to look through you, and that simplifies. Well, let's keep all of it, but I want to comment you out for now, because if I want to, I want to be able to roll back to this. I feel like it was more traditional to the game to have it so that all the centipede pieces bounced off the wall, but it just doesn't look quite right as you speed things up. And I'd have to look to see how far it goes. So we just need to loop through all the mushrooms, and we just need to look through the parent mushroom, which is going to be 0. So const current mushroom, we just need to say const parent segment is going to be equal to this dot segments 0. And then we can say parent segment. Yeah, when the parent segment collides, and then in our game we can enable the mushroom collisions again. Yeah. Handle mushroom collisions. Bounce off the wall. Bounce. Bounce. Oh no. Oh no. Nope, that didn't work. Handle. So it collided with mushroom. If hit, boundary collision handler. If it's a mushroom, we move this distance, this dot x. We move that distance. And no, that should be fine. If allow move vertically, when does this happen? But we never collided. So why didn't we collide? Collided with mushroom. This dot diameter. Bounce compensation. This dot vector. We just need this dot. It's not y. Let's see if that fixes it. Because we actually don't care about the vector for this. Kind of went around it, not quite the behavior I want. Let's see if we can refresh and get better bounce. Let's see, you hit that. Bounce, bounce. I think that's okay. Bounce, 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 bounce. Oh yeah, no, that's not so bad. It's not as mechanical, but I think it's a little bit smoother. Yeah. We could have the items stack up on each other. And I think I could do that by having a small delay, so it will all, I think, yeah, hold on. We don't have it handling the bullets yet. But let's come back over here to our centipede. And this is the problem. I'll create a branch for this so that I keep all of this and then clean up some of these comments. Let's do that a while, actually. Let's come over to our code. I'm going to do that off screen just because, you know, I don't want everyone to see my Git information. D drive, CD code, and let's do a Centipede program called Centipede. CD Centipede. Yeah, go in and get an it. Create a repository for you. GitHub repository. All you not Centipede. Private for now. Create the repository. So steps to add in our repository. Create a branch. We'll get add to it. Push. Um, da, da, da. Oh yeah, git commit. Additional commits. Git push. Cool. All right. So now we've pushed up, and now we can start removing some of this stuff. So that now we can kind of clean this up a little bit, in case we want to. Now, we don't have to now. This also makes it a little easier because now we don't have to run all the collisions through each of the individual pieces. So let's go ahead and add in our collisions for the top and the bottom. Collided with top, collided with bottom. So let's add you in. And again, the parent's the only thing that has to worry about this. Not every segment. Collided with the top, collided with the bottom. No need for the vector. Yeah, collided with the top, collided with the bottom. And let's add you guys in here. Collided with top, collided with bottom. All right. And next, the only thing we have to worry about is the bullet collision. Let's clean you up as well. Let's do the collided with bullet. Bullet collision. You never went away. And I don't need this array anymore of collided bullets, but yeah, you never went away. Yeah, to loop through all the segments. And the segments all now need to be able to deal with collided with circular object. And each segment needs this particular function. So return this dot x versus this dot y, that diameter, which is set for everything, and I think we're good. So we have our 3 segments, which I can hit because I'm a terrible shot. No. 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 All right. All right. All right. All right. Move vertically is not a function. Collided with circular object. If start piece. We have to move you vertically. I guess we should make you more universal. So let's go over and make them move vertically. Let's make this move vertically. This that vertical move. This that vertical move. That means I need to move a few things. Let's say this dot hit bottom is false. And this dot move vertically. This dot, wait, what? This dot, what? Where is this? Oh, okay, yeah, this is what we want to move. Parent, and we want to move you into all segments. This dot vertical move is that, so it's there everywhere, and where, and so then we got to move this dot vertical direction is down, view into the parent. By default, we move down. And let's then move vertically into a more universal spot. We have to move horizontally too. So let's see. Let's try that again. Let's delete some mushrooms. I think there'll probably be another bug. Almost. Oh, I know why. And the follow logic is off then too when we move slower. So because we move slower, should you be a variation? I think I'm going to have to figure that out. I think when we're moving slower, you created a new Centipede, didn't we? We did. We created a new Centipede at X and Y. Let's see what happens. It's going to miss because I suck at aiming. There we go. You moved a bit slower. Do we not know how many pieces we have? I'm going to have to look at all that logic again, aren't I? Yes, I am. And that's because I hard-coded in some values. Look at me being a dumb mushroom helper. Mushroom details. Find closest cell. Yep, there it is. So it's no longer mushroom details. Mushroom details? Where are your mushroom details? Create single mushroom. Find closest mushroom. This is in find closest cell. It's just X and Y now. And so that's good. So you should be fixed. But I also need to change it so that the centipede size is and bullets. This dot start, create segments. And we need to this dot length. The length is equal to that. Why are you only making 3? Why are you only making 3? What? So we change the direction, which is fine. We create a segment with the custom direction. We loop through this dot length. And we go plus plus. So it don't create that many. And we do the move, handle bullet collision. Let's take you out, you're no longer needed. Move horizontally, you're no longer needed, but we'll keep you for now. Draw, we go through 0 through the segment length. And the number that we should create. Why are you wrong? You were wrong. Wrong, we're wrong. New centipede.length. Oh, because my centipede calculator is wrong. Look at me. When we handle bullet collision, we need to know the length. To move vertically, we want to take the segments and slice from 0 to I. Piece, we splice you off. Pick one to move down a direction, and the new centipedes are going to be equal to that. And this dot segment slice dot length I. Segments dot length. Okay. Okay. No, that should all be right. We didn't change this logic. Something is wrong again. So, we splice I. You're spliced. Yeah, no, none of that should change. Let's go back up to our game and increase the length of our centipede. 2, 2. We see 2? 10? I guess we want 9. And that's where I'm messing up. So we should actually come back up here to our segments, create segments. There's always going to be 1, and then we want to go to 1 to less than length. And then it bounces. That's right. I had to get rid of our mushrooms to try to get that one right. Okay. All right. So it does separate out correctly. And how do I know what speed to go? I guess I'll just have to calculate that. Let's take a look. So you're working all right. Let's slow down the lerping piece. Let's add a brief delay. When it collides, do we want to add a brief delay? So it collides and speeds up. I guess when it collides it should speed up. Oh, I don't know. And the speed that we should use. So how do we get out of the game? We create a new centipede. Its speed is 1.5. Actually, I wonder, so should the speed and the distance be just 0.15? Let's see, 0.15. That's not terrible. Does 0.14 give us? Nope. 0.12. 0.12 seems to be the one I want to use, and actually 0.13. Yep. So what we're going to do is the speed is going to be calculated by Let's put in this, pass in the speed. Speed is going to be equal to current speed times, what does that give us? Let's open up our calculator. So 1 times 0.10001. So 1 times 0.01. 1 times, it's 1 divided by 1000. So 1 divided by 100. 0.01. No, 1 divided by 10. Yeah. So it's going to be the current speed divided by 10 minus 0.02. And that may have to change. So when we adjust ourselves, the new speed of x, no. So, yeah, let's give it a try. Let's do that. Const new speed is going to be equal to speed divided by 2 or 10 times or minus 0.2. So let's see what that breaks. Okay. And what happens when you get shot? Oh, that's not bad. It's not quite as fast as the other one. So let's see what the variation is when we do 1. So that's a speed of 1.5. That's a speed of 1. And let's see what we want to do for the speed over here. So instead of being 0.12, what would be 1 divided by 10 minus 0.02 gives us 0.08. So do we want to be 0.07? 0.07? And maybe we only want to change the x. Nope. We want to change the y too. Oh, it's too much space. 0.09. Yep, we want to be 0.09. So let's change you and see if that looks any better. And I think I'm okay with more of the curvier approach. Oh. Okay. And now what happens when we change you to 1.5? Still a little off. Because we're doing 1.5 divided by 10 minus 0.01. Calculate that consistently. I guess we should just use a table. Because when we go to 2, that's not going to be okay. 2 is going to need to be what? Let's look at that. That's going to be 2 divided by 10 minus 0.03. I think that's the thing. As it increases, we need to adjust it accordingly. So if it's going to be minus 0.01, minus 0.02, minus 0.03, and go that way. I think that's still a little too close. Nope. 6. Yeah, so it's going to be 1, 2, 4. Let's see what happens when we go up a little bit more. 1, 2, 4, so 2.5 is going to be equal to 1, 2, so that's going to be 2.5 divided by 10, and it's going to be minus 0.0248. So will it stay the same and be 17, or is it going to be minus 4? Nope, I think it's going to be minus 4. So 2.5 divided by 10 minus 0.04, so 0.06. So is it going to be 19? And if that's going to be the pattern, that's fine. 19's too slow. Or too fast. Nope. Also 16 is not good enough. 0.20. I might just have to like pattern these out. No, I messed up. 0.20. So it is 0.19. Yep, 0.19. So it looks like it's 0.5. How do we do that? So it's going to be 1, 2, 2.5 divided by 10 minus 0.06. Yep. And then the next one would be 8. So we start off as 1.1. And I guess we'll use a chart. We'll just map it out. So it would be 0.01, 0.02, 0.04, 0.06, and then after that 0.08. So 2486. Let's see what it is. Let's go up to 3, and that's going to be 3 divided by 10 minus 0.08 is 0.22, and let's see if that gives us what we want. Yep. So yeah, that's going to be the pattern. Yeah. And let's console log our speed here just to be sure. Yep, it's 3. So for the levels, this is in the child segment. That kind of simplifies things. I think we'll leave some of this code in here, but in our types code, let's put it in here, export. And I guess we should use a map. Yeah, we could use a map. Yeah, let's use a map because then we can use numbers. JS map. Yeah. Centipede speeds. And centipede speeds dot set. And you're going to be, what is it? I had it over here. Yeah. There's our parent. There is our child. And types. Here's a comment. So when the speed is equal to 1, it's 0.01. When the speed is equal to 1.5, it's 0.02. When the speed is equal to 2, it's 0.04. And I'm sure there's somebody out there who can do the math and kind of get this consistently. But it's eluding me at the moment. 3 is going to be 0.06 and 0.08. So then to get it, we can just do map.get. Yep. So yeah, we'll just do then Centipede. We'll get the speed in. We'll call you const lerp speed. It's going to be equal to centipede.speeds.get our speed, and we'll put it in here as a lerp speed. And then by default, as we go through the game, let centipede speed equal. We'll start off as 1. Create new centipedes, you will be the same. Now, when there are no more centipedes on the board, we need to manage score, loop in game, start, display game over. We need to generically create new mushrooms, and we need to increment the number of mushrooms we create. Mushrooms to create, we'll start off with 20. And we'll have a let here. So, when there are no mushrooms it's greater than 0, then return. And we need to advance a level. Const created here. Const advance level. And I'll write some additional rules in here. So when we advance level, we take our mushrooms to create and we ++. And we need to take our mushrooms to create is that. And ship lives is fine. We don't change the score. I guess we rerun setup. Let's take a look. P5 and C. So P5. Redraw. Setup. Let's see. Redraw. Is there a resetup? Value in setup function. And it shouldn't be called again. So we need to, once it's gone, we need to create a new centipede. And we need to create a new centipede. And we don't need to create a new ship. The spiders will keep going. And so advanced level. And then we push in a new centipede. Increase centipede speed on certain levels. And then the mushrooms to create we do here. We don't need to create the grid again. So then we come down here to advance a level. Mushrooms create. And we'll create a level here. And when we advance, we level +1, we plus the level. So key pressed, mouse pressed, in-game, manage ship. I just did it. I just put the code in here. Yes, here it is. Level ++. Increase the centipede speed on certain levels and increase the centipedes. So every 5 levels, let's give them another centipede. And we should pick a new random direction. Yep. So every 5 levels, yeah, let's create a new direction, left, right, and then put in the new direction, custom direction. Yep, there it is. I don't think we have custom direction being handled yet. Do we? I don't think we do. Let's go ahead and handle that then. And then we need to. So we're getting closer to the end. Yeah, we'll map.random new here. So we'll pick a new direction. Math.random directions.right left. Oh, math.random new direction. And then under centipede, when we want to create a new one, generate a new direction, centipede, this.vector, custom direction. I don't know why we're even bothering to put in a. Are we using this vector at all? I don't think we're using this vector. I don't know why we're bothering. And we are using custom direction. We are using horizontal direction. Yeah, let's make sure this works. Let's go ahead and open you up. Let's see. I think we're getting closer. No, I broke something. I think I got rid of vector but left it in. Yeah, I did. I left it in places that it doesn't need to be. Just parent is just equal to x and y. I don't know why I'm doing that. You're handling that on the parent. There's just no need for it. Then yep. Wow. That's a pretty cool effect, but like, what? This dot x dot move distance. So leaving that in there worked better? Is that right? No, I don't think that's right. I don't think vector was the problem. I think it's the lerp speed. What do you think the lerp speed is? Well, let's go look. Speeds.get. Console.log lerp speed. Let's take a look at what you think the lerp speed is. 0.01. Oh, that's me. I messed up here in types. It should be 0.1. 1 point. Wait, is that right? Isn't it 0.9? Or is it 0.1? 0.1, I think it is. No. 0.8. No. 1.08? No, it's 0.07. No, 0.099. Yeah. And then you were 1 point. So you current speed minus 1 minus 0.02, so 0.13? Yeah. And you were basically 2 divided by 10 minus 0.04, so 0.16. 0.16. And then you were 2.5 divided by 10 minus 0.06, which is 0.19. And then you were 3 divided by 10 minus 0.08, which is 0.22. So that fixes you. Let's see, I don't actually have it advancing levels yet. So we have to get collidable mushrooms, advanced levels. That advances the level, and let's make sure that at least works. I guess we could have it change colors too. When that happens, we should change the colors of the centipede. We don't need the console log view. We should change the default color. Yeah. So let's see how that works. Okay. Nope. 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 I messed up somewhere. First segment dot collided with edge is not a function. I thought collided with edge was everywhere. Collided with edge was everywhere. Collided with circular object. You're there. What do you think you are? Oh, we'll have to get back to you. Because it doesn't look like you drew yourself correctly. Oh, well, there goes my ship. I see. So first segment doesn't exist. So I see. I must have, when generating a child piece, it wanted to collide with the edge, and it's not there. I'll have to come back to this. All right. I think that's where I'm going to end it today. I'm going to go ahead and push this up to the repository. And here's our command window. Command. CD code. CD centipede. Git commit -m. Modified centipede behavior. Added level advancement. Good push. All right. So we've added up that, and we'll go ahead and continue working on this on Sunday night. Thank you very much, everyone, for tuning in. Again, we've made some progress. We have a slightly smoother function, and I don't know it. Like I'm kind of going back and forth between this. So like it's not bad, but nope. Yep, looks like I found a problem there. So we'll have to kind of play around with that. I think I may need to put back the old behavior because it looks like this one just doesn't. It's not as nice. Yep, it's just not as nice. All right. Thank you, everyone, for tuning in. I'll have to continue working on this and see what happens. Yeah, please feel free to drop me a line or ask me any questions if you have any, and I'll try to answer them. Everyone have a good weekend.